In this tutorial, we're going to look at simplifying rational expressions. Now, a rational expression is what we've defined earlier in the year as basically anything that can be written in fraction form. So something like this, 6x over 15, is considered a rational expression. And what we want to do is simplify it just as we would with regular everyday fractions. The idea being that fractions can be reduced anytime the numerator and the denominator share common factors. So in this case, we would do something like this. 6x could be broken up into 2 times 3 times x. 15 could be broken up into 3 times 5. And because 3 divided by 3 is 1, and anything times 1 is the same number, it essentially just disappears. And so what we get is 2x over 5. Now all we're going to do is we're going to take this idea much further. And now that we're familiar with polynomials and factoring, especially things like this, we can take this same concept to simplify this problem. 6x minus 15 over 14x minus 35. Now in this case, when I think factoring, I want to be thinking distributive property, except in reverse. 6x minus 15, these both share a common factor of 3, and the leftovers would be 2x, 3 times 2x is 6x, minus, and then 5, because 3 times 5 is 15. Now we apply the same logic to the bottom. 4x minus 35, those both share a common factor of 7, and 7 times 2x would give us 14x, 7 times 5 is 35. Now in this case, it's not the numbers that match up, but it's our leftovers, these binomials, 2x minus 5, 2x minus 5. But again, because I'm multiplying with them here and here, they're essentially factors. 2x minus 5, it's its own factor. Same with the one on the bottom. So those, 2x minus 5 divided by 2x minus 5 become 1, disappear. And what remains becomes my answer, 3/7. Now, this even works with more than just binomials. Now, on this one, x squared plus 3x plus 2 over 5x plus 5. On the bottom, I can do the same thing. I can easily see there's a common factor of 5, and I can do distributive property. But now on the top, trinomials are a little bit different. Here we've got some different methods that we can depend on. If you're the type that does a lot of mental math and remembers our acronym of FOIL, first, outer, inner, last, you could use this. If you're more the visual type, we've done this using the generic rectangles and using basically a miniature multiplication grid to factor that problem, or we've also learned how to factor by grouping. And any of these methods is fine. For me, I'm going to stick to FOIL only because, and for sake of time for this tutorial, it'll be the quickest for me. So here, I just run through the acronym in my head. First term times first term would give me x squared, and there's only one possibility there. It must have been x times x. Then I jump to my last term, 2. And the only way that could happen, last term times last term, it must have been 1 times 2. And that works for our 3x, because the 3x is of course a combination of the outer and the inner multiplication. Outer would be x times 2, which is 2x. Inner would be 1 times x, which is 1x. 2x and 1x combined give us 3x. So the top factors like that. So, again, now that everything's factored and it's all just multiplication problems, I can now cancel anything that matches, in this case this factor of x plus 1 with the 1 on the bottom, and my answer becomes x plus 2 over 5. Alright, let's do 2 more, and let's specifically look at these problems where we're factoring with FOIL or generic rectangles or grouping. Alright, here's our next one. 2x squared plus 7x plus 3 over x squared plus 7x plus 12. So when I'm doing a problem this complicated, I should of course be going through my factoring checklist. I can see on the numerator there's no common factor to take out. It's not the perfect squares or difference of squares shortcut. So in this case, again, I'm going to do FOIL or grouping or generic rectangles. In this case, again, we're going to do FOIL. 2x squared must have been 2x times x. And then 3 had to have been 3 times 1. But here I got to be careful how I set it up because I do want to get 7x as my middle term. And the correct way to do that would be to put the 1 here and the 3 there. 1 times 3 will give me the 3. And then when I look closer at the outer and the inner, 2x times 3 is 6x. 1 times x is 1x. 6x plus 1x gives me the 7x we wanted here. So 2x plus 1 times x plus 3. Alright, now let's go to the bottom. Let's do FOIL again because it's not a shortcut. There's no common factors to take out. X squared must have been x times x. There's no other possibility. Now 12 could be a lot of different things. 1 times 12, 2 times 6, 3 times 4. In this case I'm thinking 3 times 4 because the middle term is 7x. And if this is 3 and that's 4, 3x for the inside, 4x for the outside will give me 7x over here. So it must have been x plus 3 times x plus 4. Alright, now that everything is broken up into factors, we're allowed to cancel numerator and denominator shared factors. In this case, x plus 3 and x plus 3. And so what remains is 2x plus 1 on the top over x plus 4. Alright, one more just to finish up. Again, two trinomials, so on the top I'm thinking there's no common factor to take out, but this is the perfect square shortcut. X is a square, x squared used to be a squared number, used to be x. 9 used to be 3 before it was squared, and 3 and x, when doubled up, does give me 6x. So that must mean that the original problem was x plus 3 squared, or x plus 3 times x plus 3. And I'm going to write it out the long way here because I do want to keep them separate, so in case I cancel one but not the other, I don't accidentally cross both of them out. Now on the bottom though, first thing I check for is a common factor, which I do see, 2. So before I do anything else, let's take that 2 out, which gives me x squared plus 10x plus 42 as leftovers. Now I can work on this part. It's not a shortcut, so I'm going to have to do this the long way. In this case, we're going to go x plus 3 times x plus 3 on top and just recopy. On the bottom, we've taken out the 2. And if I think FOIL, x squared, again, must have been x times x. 21, either 21 times 1 or 7 times 3, but considering the middle is 10x, I'm thinking 7 and 3. Because here, 7x and 3x will add up to 10x. Alright, so there's the problem completely factored. The top has 2 factors, the bottom has 3, but all I really care about is the ones that match up. In this case, 1 factor of x plus 3 on top, 1 factor of x plus 3 on the bottom cancels out. Notice how I'm not canceling this one out. It has to be a 1-to-1 correspondence. So on top I get x plus 3 over 2 times x plus 7. Alright, so this is a little bit about simplifying rational expressions. It's just this idea that we can treat these just like regular fractions, except it's the factors that we look for that are much more complicated. We're no longer just looking for numerical factors, but we're looking for polynomial factors. Alright, and so one last note right here, this last problem. If sometimes your book or your teacher wants it left in factored form, it is okay to leave it broken up like this. Other times your teacher may ask you to completely clean it up. Now that we've taken care of the common factor here, we may want to write this answer like this and redistribute the 2. But it all kind of depends on what you're working on and what your teacher wants. So, yep, that's simplifying rational expressions. I hope this helps you out. And if there's any part that was a little bit unclear, always, of course, go back and rewind and rewatch the video.